In machine learning, the term tensor can mean two things. First, it's a way to organize data into a multidimensional array, known as a data tensor. Second, in mathematics, a tensor is a multilinear mapping over sets of vector spaces. Images, sounds, and relationships among words can all be stored in data tensors. These can be analyzed by neural networks or with specialized tensor methods. Tensor decomposition breaks down data tensors into smaller, more manageable parts. Operations on tensors often use matrix multiplication and the Kronecker product. Software libraries like PyTorch and TensorFlow help compute gradients, which are essential for training neural networks. These calculations are usually done on graphics processing units, or GPUs, and on custom hardware like Google's Tensor Processing Unit or NVIDIA's Tensor Core. This has allowed neural networks to become larger and more complex. Historically, tensors were used in mathematics and physics to describe relationships and mechanics. In machine learning, their use depends on the statistical approach. By the early 2000s, tensor methods were adopted in fields like computer vision and graphics. Multilinear algebra, the study of higher-order tensors, helps analyze complex data and disentangle different causal factors. For example, a collection of facial images can be organized into a data tensor, with each dimension representing a different factor like facial geometry, expression, lighting, or viewpoint. Tensor factorization methods, such as tensor faces, break down this data into simpler parts to learn about these factors. In neural networks, tensors can represent unit values extending from scalars and vectors to multiple dimensions. In convolutional neural networks, each unit might be an image or a video, allowing the network to learn from complex data. Tensors are also used in fully connected layers, where the output values are computed as tensor products of the inputs and weights. In convolutional layers, tensors express the filtering process that detects features in images. One important use of tensors is factorization, which reduces data into essential components. Tucker decomposition, for instance, breaks a tensor into smaller matrices and a core tensor, reducing the total number of elements. For very large tensors, tensor train decomposition rewrites them as a sequence of smaller tensors. Tensors have also enabled new machine learning architectures like tensor graph convolutional networks, which can analyze complex dynamic data. Training large neural networks is computationally expensive, but advances in hardware have made it possible. NVIDIA's CUDA and cuDNN libraries use GPUs for parallel computation. Google's Tensor Processing Unit and NVIDIA's Tensor Cores are specialized hardware that accelerate tensor operations. In 2022, Google's Palm was the largest neural network with 540 billion parameters. Models like GPT-3 and Llama have also pushed the boundaries of what's possible. Tensors are at the heart of modern machine learning, powering everything from image recognition to natural language processing. Like, share, and subscribe to SoftTech Explorer.